All right, we are back. So T-minus 1 lectures to go. Tonight we finish our look at iOS and some of the features that we've hinted at thus far and that might empower you to do some pretty cool things with your third and final project. In fact, looking ahead to exactly that, on Wednesday, August 7th, in lieu of lecture, we'll have an app party of sorts whereby we'll convene across the hall where labs usually are held. We'll bring in some snacks and food and whatnot, and you'll bring your laptops and or iOS devices, and the goal will be to spend an hour or so exhibiting each other's work and chatting and sort of debriefing how the semester went and showing off what you're hopefully quite proud of, whether that's your final project or either of the prior two. And leading up to that next Monday will be a couple of guest lectures. So I and all the TFs will be here, but we thought we'd invite a couple of friends. One is a fellow named Dan Armendariz, who used to co-teach this class and taught an Android aspect of it. What we thought we'd do is give everyone some exposure to what Android programming is like, what's similar, what's different, so that you can scratch that surface and see if that's a direction you might like to go in next. And we'll also have a friend of ours from Microsoft, Bob Familiar, join us to talk about Windows mobile programming, taking a look at how you might do it with C#, which is Microsoft's language for desktop and mobile programming, as well as how you might also do it using HTML5. So that'll be our final glance at the semester. And we'll also tie up loose ends with iOS and give you a sense of where you can go from here and what you might want to keep in mind so that once the training wheels are off, you can actually create some cool things on your own, if indeed of interest. So with that said, how would we go about making something like this? So we saw our first application involving Rob last week, and what were the features we implemented atop Rob's 3 photos last time? Yeah. Gestures. So we had a couple of gestures. We were able to swipe from left to right to move Rob from one side to the other, or from right to left in order to pan through his 3 Facebook photos. Thank you for sending him those Facebook friend requests so quickly, incidentally. And we also had one other feature that we implemented atop Rob's face, which was what? Alerts. OK, but we'd seen alerts before. How did we trigger that alert last time? Yeah, so touching down or a long press, where if you hold for a good second or two, that is a separate event that's fired that we caught in code, and we said, hey, stop that, or something similar. So we had 2 such gestures, but we didn't really do a couple of the more familiar mechanisms whereby I might, for instance, want to just move something around. Now, this is a little underwhelming on a backdrop, but because this is rectangular, you could imagine having images or shapes of some sort where it would make sense to actually move these things around. And in fact, where we'll end tonight is actually looking at how to do this programmatically. How do you create 2-dimensional graphics that move in response to user actions or just move around on the screen on their own? So this is a translation of sorts, moving up, down, left, or right. But what you can also do in the simulator, if you hold Option, you'll see that my cursor is flanked by a second circle, and these represent 2 fingers. So you can actually mimic the idea of pinching, even though you can't touch your laptop screen. And if we do this, we can zoom in on Rob's denim shirt atop denim shorts, or we can zoom out until this image gets super, super small, much like you might pinch and zoom in Maps or Google Maps or the like. So how would we go about implementing something like this? Well, let's take a look at some basic building blocks, and we'll see some similarities and some differences. This is the more complex of the ones we looked at last time. So app delegate is a good place to start. Main.m never seems to have anything of interest, so we won't even glance there for now. Does anything look anomalous, new, different in this file versus past examples? This is the appdelegate.h file. No, nothing magical there. This is just the boilerplate code that you get with the single view application. How about the .m file? If I scroll down, looks like this is the only method. Anything interesting, new, or different there? No, but it seems to be this guy, as usual, that's kickstarting the process by assigning to view controller a newly allocated view controller. It's being initialized with the nib view controller. There's no file extension, but recall that that's by default referring to the .xib file that we've had for some time now. And then finally, we're making it the key window and visible, which means foreground, whatever the contents of that nib were. Well, what is that nib? Let's take a look in the xib file. And we see Rob. For a moment, it flashed for just a moment, because that's actually because there's a couple of objects layered on here. And we can see this if I zoom in and I click on View. Recall that View, a UI view, is the rectangular shape that we've typically laid down. And we have an image view. So this is actually a different class that we haven't seen before. If I pull up the inspectors over here on the right and choose my identity inspector, you'll see that this is a UI image view. And this is like a container for actual images. And those images, as we'll see in a second, are going to take the form of UI image objects. So let's actually see how we now started listening for events atop Rob's single photo there. Well, first, let me expand supporting files. There is the photo, rob.jpg, that I configured here. And indeed, if we go back to the inspector, just to confirm, let me go up to the attributes inspector. The fact that it says rob.jpg in the top right corner, that just means that's why the image view is displaying that image. So no magic there. So the complexity must be in this guy. No, not in the viewController.h, or the one remaining candidate, viewController.m. So let's see if we can't wrap our minds around what's going on here. First, a couple of teasers. So this up here is an example of what? What Objective-C construct? Yeah. Yeah, so it's a category. It's a nameless category because there's nothing inside the parentheses, and it's a way of sort of creating the illusion of privacy in Objective-C, whereby we have apparently a private data member called cgPoint underscore translation, and cgPoint is actually something from the core graphics library. So CG, core graphics, this is referring to Apple's support for two-dimensional graphics, and we'll see that this is actually a primitive of sorts. It's not actually an object, because a lot of the code you're about to see in two-dimensional graphics actually has its origins in C. So we're going to start seeing some commingling of Objective-C and C, which is the language, recall, you took a look at when Rob was at the helm a few weeks back. So we have a couple of properties in here. One is a float called scale, and one is an image view, a UI image view called image view. And we'll come back to that in just a moment. We seem to have a couple of private methods in here. One is called handle pan, so moving left, right, up, down, and handle pinch, which is the two-finger gesture. So that's just setting the stage now to listen for those events. And if we scroll down here, what seems to be going on? Well, when is this? Yeah.
Sorry, if we could go back.
Uh-huh.
Is there any reason for using an instance variable instead of a property for cgPoint?
Is there any reason to use an instance variable rather than a property? It's a good question. What was the motivation for this? You can still do primitives. Short answer, I don't think. Yeah?
If you use an instance variable instead of a property, this will prevent outside classes from accessing that property.
Yeah, no, that's true, but I'm at the same time not doing the same when it comes to scale in image view necessarily. Let me think about why we did this the way it is, but short answer doesn't matter in this way. We don't need that functionality of the setter or getter. But a good question. I'll come back to it. All right, so init with nib name. This is the first method that's invoked here. And the init with nib name seems to be preparing a few things. So one, it's calling the superclass, which is actually doing the loading from that .xib file, which is the normal default case. And then we're apparently setting a property called scale to 1.0. And that's just a default reminder that by default, Rob is at normal scale. 100% X, 100% Y. There's no zooming in or out. And then translation X and translation Y is referring, oh, this is why. So the reason that I'm using the, cgPoint is actually something called a cstruct, which you may recall glancing at in C, which is kind of like an object that doesn't have methods associated with it. It's just a container for data. So problems actually arise because Apple chose to use the dot operator when it came to properties, but the dot operator is also used for structs. So doing it this way ensures utter clarity as to what's going on. In this particular line here that's highlighted in blue, I'm accessing the X member of the cgPoint struct, and I'm doing then the same for Y. So things get a little messy if you start commingling the two features. Came back to us. OK, so translation X, translation Y. A translation is just a shifting, up, down, left, or right, or some diagonal. And this is implying by default, Rob has not been shifted up, down, left, or right. He's just smack dab in the middle of the screen. So these are our initializations of variables. So now a few things are going on. There's a handle pan method, apparently. There's a handle pinch method. There's a viewDidLoad. Let's actually go to viewDidLoad down here. And let me hide this so we can focus on just these three. ViewDidLoad, recall, is loaded once the nib has been loaded and the view is ready to go in memory. And as the comment suggests, we're listening for two things: a pan from left to right, or top to bottom, or top down, or a pinch with two fingers. And this is code quite like we saw last week. We initialize a certain type of recognizer. We initialize it with a target that has to be self in this case. Self is referring to an object of what type at the moment? Who is self? the view controller. So presumably whatever method we are telling the recognizer to invoke when panning happens is somewhere in this class, and indeed it was higher up in the file. And then this selector syntax is just our way of saying call the method handle pan, and colon just means it takes that one argument. And then over here, what are we actually doing? We'll notice that self.imageView is our property that maps via interface builder. I dragged and dropped a little blue line connecting an IB outlet to my nib. This is saying add that recognizer to that view object on the screen. So that is the rectangular shape that's going to listen for this pan gesture. And pinching, essentially the same thing. Okay, any questions on how we set that up? Thinking back that, again, the structure is the same as last week. No? Okay. All right, so now let's look at the part that does all of the thinking. So handle pan. This is where it gets a little complex, but this is just the result of reading through exactly what each of these functions does. A lot of this, again, is C. And the first thing that happens here is that we first request from the UI image view, that container containing the image, something called a CG point translation. So this is essentially 0, 0 by default. And then the next line, we're making an affine transformation scale, which is essentially saying by how much do you want to grow or shrink Rob along the X and the Y axis. And then we go ahead and ask, make a translation. Translation refers to by how much do you want to shift Rob, to the right, to the left, up or down, or along some diagonal by adding those two axes together. And then lastly, this last line of code actually applies that transformation, that changing in scale, bigger or smaller, and that shifting up, down, left, or right to whatever the object is, which is, again, that UI image view. So those several lines of code, which are at each point essentially declaring a C struct, a C struct, a C struct that's being populated by the return values of these functions on the right-hand side, they're then being applied in this final line. So what is the role played by these last few lines down here? Why are we not done as soon as we apply the transformation? Yeah?
The user can keep hanging around, so once the user is done, you want to restore the translation.x back in, so when he pans around again, it will start from that state.
Exactly. Good, because we're doing some additive math, especially when it comes to the translation, we're taking into account where Rob began on the entire screen. So if we wanted him to not snap back to the default location each time you drag or drop him, we have to simply update those local instance variables. Yeah?
Along these lines, when I pan slowly on a screen, does this event fire several times or only once?
Good question. It does fire several times. Otherwise, if when I clicked on Rob's face, albeit in the simulator there, you wouldn't have seen anything happen until I let go. So it does fire at a particularly fast frequency so that you can respond essentially pixel by pixel. Good question. Yeah?
Is there a way to set that off, like that continuous to like?
You can change the rate. The default is set by default, but you can override it so that you can respond in different ways. Much like with the long press, by default it's roughly 2 seconds before Rob's face would have triggered that UI alert view last week, and that's who you can raise or lower programmatically when declaring the gesture recognizer. Good question. Yeah?
So can you go back to the previous, not go scrolling down?
Uh-huh.
So the reason we do it here is actually we can use IB action to do all this, right?
Say that again?
We can use IB actions instead of to like do this instead of like write down those.
So recall, these are not IB actions. So IB actions are how we declare methods inside of a class when we want objects inside of a nib to talk back at them, or more generally for UI views to talk back at them when a user interacts with them. In this case, it's the gesture recognizer, which is a class that Apple has provided with us, that is responsible for invoking these methods. So it's not quite the same use case because these messages are being passed by this recognizer class.
So for anything like in the nib, if I want to access for that, I should give a property for that.
Typically, an IB outlet property. So typically, if you want to connect your code to a interface that you created with Interface Builder in a .xib file, then yes, you do exactly that. And that is the reason why if we scroll up to the part we glossed over earlier, I have two things declared as properties. One is the scale, which as we'll see is just a way of remembering when I pinch what the scale factor is for Rob if it's not 1.0 by default. And image view is very typical. Notice that we have IB outlet here, and we've seen this in a number of examples in past weeks. This is my mechanism for actually linking my code to the UI image view so that I can actually apply that recognizer and listen for those finger touches. Good question. So pinching is going to pretty much similar in spirit, even though some of the function calls will be a little bit different. Let me scroll this over just a bit. And handle pinch is the method that's going to get invoked when you're using the two finger to go separate or closer together. And now we have this first. I'm declaring a CG float struct. So again, here too, it looks like a class, looks like an object thereof, but this is again just capitalized to be consistent with Apple's tradition for C style structures. This is a CG float, which is just some representation of a floating point value. CG affine transform scale is doing a line of code similar to before, where we take the current scale and multiply it by some factor. And notice that the factor has been passed in to us. So one of the things this recognizer does is it figures out how far away did your fingers move in that split second of time, and then it informs this method what that difference is so that you can scale accordingly. Then if we look down here, we're doing a translation. This time we're not actually moving Rob, because recall we only want to move Rob when we're panning, not when we're pinching. So he's going to stay put, but grow from wherever my fingers are moving closer or farther away from each other. And then we apply these two things again, much like we did previously. And then lastly, all we do is remember that change in scale so that when I do it again, he doesn't snap back to the default 1.0 resolution to start anew. All right. Any questions then? So we've seen some building blocks now for swiping, up, down, left, right, for touching, for pinching, for clicking and dragging. And so with those, for your third project, if you choose to do something in iOS that actually has UI interactions beyond what's possible out of the box with Interface Builder, realize that these are the basic building blocks even for, say, a simple game. And we'll put these to the test later tonight when we implement an age-old game of sorts. All right. And you might see an allusion to it right there. All right. So, questions on the basics of graphics before we move on to things that are useful to have in your toolkit, but then we'll come back full circle to the application of two-dimensional graphics, actually moving on their own without human interaction. Okay, so a design question then. So totally changing gears for just a moment. Localization refers to what process when writing code? Okay, internationalization. So not just naively assuming that every one of your users is going to speak English and read English, but rather might have some other native tongue, and you might want to cater to that audience so that they actually download your app, use your app, can understand your app, whatever the reasons. But this is problematic because we've gotten into the habit thus far of writing quite a lot of code in what's essentially English, since Apple came from the US, but also quite a lot of strings, quite a lot of NS strings inside of double quotes, maybe prefixed with an @ sign. So this is kind of problematic because I feel like if I want to suddenly support Mandarin or Spanish or any other language to which I might want to localize my application, now I have to do a whole lot of copy-paste. And any file that has a quoted string like hello world, I'm going to apparently need to copy my viewcontroller.h and maybe make a separate one for each language, viewcontroller.m, a separate one for the languages. Like, surely this isn't the way. Because if there's some 50, 60 languages you might even want to support, I mean, that's a nightmare to have that much code lying around, if only because now if you want to make a change, you have to make it in dozens of places. So what's a smarter approach? And let me preface this with someone who's never internationalized an application before. How would you go about solving this problem? All right. Mm-hmm.
So you potentially store all the strings that you want inplists and then just load it from the plist in your file, and I think it would automatically do it if you say like this plist is for US version, this plist is for German version.
Uh-huh.
And then I think it might automatically just do that based on what the user's language is set.
Yeah, so that's exactly right. And the principle that I'll highlight there is the fact that you're proposing that we factor out the strings. So you can write all of your code in English or pseudo-English in Objective-C or C or whatever the language is. But if you at least factor out the strings that have to change based on the user's end language by putting them in some central file, now you can keep separate your code, your business logic, so to speak, from your actual data. In this case, the strings that the user sees. So you're indeed right. The way Apple typically does this for desktop or iOS applications is you have a plist file, which is just an XML file underneath the hood. But so far as we care, it's just a text file that we can therefore edit. And if we have a separate file for English, a separate file for Mandarin, a separate file for Spanish, we can essentially tell iOS, the operating system, depending on what language the user's iPhone or iPad is in, load the appropriate plist file for me. So in fact, you've seen a few different things. We'll use a file that typically ends in .strings, but it's the same exact idea. And it's even simpler than a plist in that we just write things in the form of text, no XML whatsoever. So let's go ahead and do an example here. Let me open up Xcode, create a new project with just a single view. Let me then proceed to name this, let's say, Hola 1. I'll bias things toward English and Spanish for now. I'm going to go ahead and leave automatic reference counting checked. I'm going to leave everything else unchecked. I'm going to go ahead and click Next. I'm going to go ahead and save this on my desktop. And now I have the simplest of applications, which, recall, if I run it, just gives me a big white box in the form of an application that looks like this. So very underwhelming, but let's make it a little sexier by going into the nib file. Let me go ahead and drag a label into the middle. Just so I can support iPhone 4 and iPhone 5s. Let me go ahead and click down here, if you haven't noticed this little control bar, and turn on a constraint called vertical center. This will ensure that whatever simulator you're using or whatever device you're using, at least this text will be vertically centered. And by default, let me go ahead and just make the American centric version, Hello World. All right, so now notice what I have in the left-hand side of my screen. All of the familiar files. The program happens to be called Hola, but that's just because I wrote that. Nothing has been actually internationalized yet. But those are all pretty much familiar files. In particular, notice that there's just a single nib file. But if I now want to localize this application, we can do the following. And unfortunately, this feature changes location with every version of Xcode, it seems. But if I go ahead and click on the project at top left, then click on the project to the right of that, you'll notice down here that there's a screen related to localizations, aka internationalization. And if I go ahead and click the plus here, I have a whole bunch of languages that Xcode supports nicely right out of the box. I'm going to go ahead and choose Spanish. And if I zoom out, I'm now being prompted to do a couple of things. Choose files and reference language to create Spanish localization. So it turns out that by default, there's two different files that can take on some other language. One is the nib file, apparently, and one is a file called info plist.strings. So I'm not going to touch the latter just yet. I'm going to uncheck it and come back to that. But I am going to tell Xcode to localize my nib file. So if I go down here to finish, what I now get is both English and Spanish. And if I go back to my nib, notice that by default, I still see Hello World. But notice what's different about the nib at top left. Yeah, it looks like it's become a hierarchy of sorts. If I expand this triangle, I seem to have English, which is what I had a moment ago, and then I have Spanish, which is apparently the same. Okay, so it actually hasn't done any translation for me. That's for a human to actually do. But I can go into this nib now, and I can say something like, Hola, mundo. Change it there, save it, and now I have my English version and my Spanish version. So let's see what now happens. I'm going to go back to the simulator. Or rather, let me go ahead and spawn the simulator by running the code. It's been built. It's being installed into the simulator. And when it comes to the foreground, we should see Hello World. Now let me disclaim, about every fifth time I try this on different computers, it doesn't work. So if it blows up, realize I've issued a disclaimer, which means it's OK. But if I now go here, these are just all the applications we've been installing in recent weeks. I'm going to right-click over to the settings. And if you've never done this on your own phone or iPad, you can go to General, International, Language. And I'm going to choose Español for Spanish. Done. It's going to change language, ... Xcode's going to crash because it doesn't like it when you do that with it still running. But I'm going to go ahead now and rerun the simulator. And now we have a Spanish version of the application. So the only thing that's changed, crash aside, is that I changed the settings in my application to actually be Spanish instead of English. And if I went back to English, I should hopefully see hello world instead. But a couple of things haven't changed. In particular, what's the name of this application apparently? So it's still Hola 1. So irrespective of the language my phone is configured with, the application is still the same. And maybe that's a good thing. Maybe you want the game to be called Angry Birds no matter what the language actually is. Or maybe you want to localize that too. So you can do that in different places. So let me actually go ahead and open up a second example here whereby we start fresh. Single view application. Hola 2 will be this application. Whoops. And save it on the desktop. And let's do something that's almost the same, but this time I want to do a little bit more in code. So I'm going to go ahead and open up my nib file. This time I'm going to drag my label, and I'm not going to hard code it into the nib, because recall that if we do a little bit more programming, we can actually control that label programmatically from code. So if I want to do this, let me make sure things line up with the online code so that you can play along at home after. If I want to actually do this, what's the first thing I need to do to wire my code up to my nib file? Because recall, all I have is the empty boilerplate code thus far. Yeah?
You need to create an IB outlet.
OK, so I need to create an IB outlet. It likely belongs in what file? OK, so somewhere in the view controller. And early on, recall that we put almost all of our properties just by convention into the .h file. But then gradually last week, we started moving more and more of our properties and method declarations into the .m file, the implementation file, just because there's really no reason to inform the whole world what our private implementation details are. So I'll go ahead and open up viewcontroller.m, and I can implement this inside of my nameless category. So I'm going to declare a property with a few attributes, but we'll come back to that. It's going to be a UI label, and I'll just call this label. Now I need a couple of more things. If this is going to be an IB outlet, I need to say IB outlet. And what attributes would be appropriate for this outlet, for this IB outlet? Well, one is always easy. We haven't seen atomic, so non-atomic is fine. We're not writing multi-threaded code here within this application. Read only or read write? The goal is to recreate the Hello World application, by this time in code, telling it what to say, either Hello World or Hola Mundo. OK, so read write, since I want to be able to change what it's pointing at. And then lastly, I can actually go with weak. So we haven't spent too much time on this, but recall that strong versus weak somehow relates to how the pointers are going to be dealt with. And in this case, weak suffices, because all I need is a pointer to a UI label. But I'm not the owner of that UI label per se. The owner is really the nib file. And when the nib is loaded, it will take care of ensuring that the RAM that's necessary to store that label on the screen will be allocated by it. I am just some other guy, viewcontroller.m, that similarly wants to talk to that pointer, but it's not really mine per se, so weak suffices. Someone else owns it. I did not instantiate it myself. It came from the nib. So after this, I now have programmatic access to the label. So what do I want to do? Well, I'm going to get rid of the did receive memory warning. There's not much we can do if this application runs out of memory, because there's terribly little going on, just that UI label. And I am going to put some additional code into viewDidLoad. First, again, by convention, I'm going to call the parent class's viewDidLoad method, whatever that happens to do. And when this view loads, so when the nib is loaded from disk, and the rectangle is constructed, and that UI label is placed in the middle of the screen, I want to do one last configuration detail, namely self.label.text. .text is what's actually inside of that label, is going to get, and this is the new part, ns localized string. And now, according to Xcode's prompts here, it wants a key and or a comment. So I somehow need to provide it with an identifier for that string. It doesn't want me to put, for instance, hello world per se, but rather a generic key that's going to be defined in two different places, two separate files, so that I can look up that value dynamically. So comment, I'm going to actually leave nil. Comment is just for really the humans doing the translations. If you can use tools to automatically generate a file we're about to generate manually, so that if you are the programmer who maybe only speaks English, but you want to tell other developers who actually speak multiple languages what this string represents, you can do it in the form of a comment there, so that when they automatically generate the file we're about to generate manually, they know what you mean by that key. So I'm going to choose something arbitrary but sensible, like greeting. So quote-unquote greeting is not what I want the user to see. It's just going to be a key into a table of strings. So to create this, I'm going to go up to File, New, File. And we haven't seen this one before, but if you poke around, you'll start seeing some other useful things. If I go to Resource, notice there's a few resources here. Property list we've seen before. Strings file is another. And according to the description, it is an empty strings file. It's just a text file. So let's go ahead and click Next. By default, I'm going to call this localizable.strings. And Xcode knows by default to look for a file by that name. And if it's present, go ahead and allow the user to define multiple languages, strings in there. So I click Create. And now I have this text file over on the left-hand side. Notice that there's just some generic comments at the top. And it's in here where I can now define some key value pairs. All right, so now if I want to go ahead and define a key value pair, let's go ahead and define what? Greeting has to map to what? Hello world or hola mundo. And then we're going to need to do that not in the same file, but in two different places. So before we do that, let me go up to my project settings as before. Hola2 is the project. And let me go ahead and add proactively Spanish. Unfortunately, by default, Xcode only seems to know about these two default files, viewcontroller.nib and infoplist.strings. We're not doing anything with the nib this time, so just to keep things clean, I'm going to uncheck that. Infoplist.strings we'll come back to, and now I have a Spanish language, but unfortunately I haven't solved the problem at hand. And this is really just an annoying UI decision. Notice on the right-hand side here, if you want to localize a .strings file that I have created myself manually, unfortunately you have to click this big button called Localize, and here's where I'll be prompted, oh, do I want to localize this file into which language? Spanish. Now I'll go ahead and localize, and now, that did not behave. Oh, there it is. By default, Xcode does not check both boxes, so if we now check English, and now go over here on the left, localizable.strings has both English and Spanish forms. So if we fast forward now to the climax of this example, what we'll see is an example that has both the Spanish version and the English version exactly as follows. In Hola2, we have supporting files, and if we go to localizable.strings, specifically the English one, notice that again, this is just a mapping of keys to values. Quote-unquote greeting equals quote-unquote hello world. Notice that it's not an NS string. These are C-style strings now, so there's no @ signs involved in this file, but they do end with a semicolon at the end. If I go to the Spanish version, the key is the same, so you don't localize that, but the value does change. And so because this file is called localizable.strings, iOS will load it automatically for you and use that when you call the function that we did earlier called NSLocalizedString. And there's one last thing I did here in advance. In this file, which to date we have not actually looked at, infoplist.strings, according to the documentation, if you define a key called cfBundleDisplayName, you can also change the name of your application programmatically. So in this case, I want my application to be called Hola, but if the user is English speaking, I want it to be called Hello. So no more Hola1, Hola2. This is the formal name for my application. If I go ahead and run this, I'm still in the simulator here. So we should see now the second version of this code. Voila. Hola mundo. And if I now go back to the desktop and take a look at the program's name, it's Hola. If I go back to English, that should change to hello, and the string should go to hello world. So sort of lesson learned here, especially if you're planning on doing something for the App Store and you actually do want to appeal to multiple languages, this is the sort of thing where it's good to start designing your strings files now so that you don't, after writing 2,000 lines of code, have to go back in and start ripping things out and redefining key value pairs. If this isn't a problem, if you have no expectation of localizing, not a big deal, but it is this easy. And it's a lot easier to do at the beginning, even if you just have a localizable.strings with only English, because just think how trivial it is when you make a friend who speaks Spanish and he or she can then translate your whole app for you just by your sending him or her that text file to send back to you to import into the project. Yeah?
Just for example, French, does iOS choose randomly English or Spanish, or is you default first few was English?
Good question. You, by default, there's still one primary language, and in this case it's English, because that's what I started with. So what would happen is you would get the English version by default, if the user has chosen some language that your app doesn't explicitly support.
So if I can start, for example, with Dutch.
Good question. Most likely, if Mac OS is configured for Dutch, and therefore Xcode is as well, when you download it from the Dutch App Store, I believe that's what will happen, but I've not had occasion to test that. Other questions? All right, so where can we take things from here? So I'd propose that from here, there's a couple of gaps we can fill in before moving on to a climax, albeit a 1980s style climax of a two-dimensional game, but SQLite. Let's add one other tool to your toolkit. What was SQLite all about?
Flat file relational database.
Okay, good. So it's a flat file relational database. So this is just a fancy way of saying there's no server involved. There's just a big binary file that can sit inside of your application that can create the illusion of a database to your application, namely a SQL database. And a SQL database allows you to do searches and queries along the lines of select and insert and delete and update. And even if you're not familiar with that, those four letters together compose a paradigm called CRUD, C-R-U-D, for create, read, update, delete, which is a very common paradigm for talking to a database, which essentially lets you do anything. You can read from it, you can write to it, you can update things, you can delete things, you can store data in read-write fashion. So why would you care to use SQL in this database language as opposed to just using a plist like we've been using for the second project, or even a .strings file if you just have a list of strings, or some other file format altogether? Speed? In what sense?
It would take a lot more time to have to read and write some files than it would to sort of like make a dictionary or an array and process the data.
For sure. Certainly for large data sets where you have thousands, tens of thousands, hundreds of thousands of records, if you stored it in a plist, well, by default, that's just an XML file. So really, it's just a big, long list. So if you were to do searches on a property list, you essentially devolve into linear search. And then in the worst case, maybe the string you're looking for in the dictionary is at the end of that plist file. So it's going to take you thousands or tens of thousands of reads in order to find the word you're looking for. By contrast, if you use an actual database, whether it's MySQL or Oracle in the real world, or SQLite in a constrained environment like this, you can say something like select the word that starts with Z. So I'm using sort of pseudocode verbally, but you can express yourself more precisely. Select the word that starts with Z. And what SQLite can do for you, if you tell it in advance, is it can give you what are called indexes, essentially tree structures that have been saved to this file that once loaded into memory allow you to search this file much faster than, say, linear search would allow you to do. So at least for large data sets, it allows you to express yourself a little more precisely than just iterating over a big list of things and to get that data more quickly. Unfortunately, for those of you who are familiar with SQL, the price you pay is in sheer complexity of the code, since to date it's still a C library, which is a pain in the neck to use when doing something as simple as we just described. But nonetheless, so that you have this expressive capability at your disposal, particularly for your third project if doing something with a decent-sized data set, let's take a look at this example called SQLite from tonight's code base. App delegate, look special? No, nothing new there. AppDelegate.m, anything going on in here? Nothing there. So hopefully the interesting stuff starts in the nib file. Okay, so apparently this app has to do with cities. No, this is just, again, stupid boilerplate appearance of any UI table view controller. So this just means the application has a table view controller. And let's actually spoil the results. Let me go ahead and run this application and see what happens inside of the simulator. And what we can see here in the simulator is that all this application does is it opens the contents of a SQLite database called small.sqlite, as we'll see shortly, and it lists those 5 words from the small plist file that we gave you for the most recent project. So what I did in advance was I wrote a little script that converted that property list file into a binary SQLite file. It's pretty easy to do. And then I included the small.sqlite file inside of the project by just dragging and dropping it from my desktop. So how is this actually behaving in this way? Well, let's take a look at viewcontroller.h. Nothing going on there. So all the logic must be in viewcontroller.m. So first of all, notice that I've declared an NS mutable array as a property called words. And this is just where I'm going to store my words when actually using them, much like you probably have for Evil Hangman after you've loaded the property list. And if I scroll down here, let me get rid of one remnant there, I have init with nib name. And this is where the nightmare begins. So, and I say this because it's just a pain in the neck to actually code SQL queries in this way, but this is the way it is not only in Objective-C, but in some other environments as well to this day. So notice I'm first initializing myself with the nib name, whatever that was, by calling the parent class. Then I'm declaring an NS mutable array here and assigning it to my property. So I just have an empty changeable array. And now, what am I doing in English, or sort of semi-technical English, with this highlighted line? What's apparently going on there, even if you've never used SQLite before? Yeah? Good. So I'm creating a pointer called db to an object of type SQLite, whatever that happens to be. It's some kind of structure, presumably. And then in that next line, notice I'm going back into Objective-C mode. The highlighted line is effectively C. So here I'm declaring a path variable that's the result of looking for the file called small of type SQLite. So this is just a fairly verbose way of saying, give me the path to the file called small.sqlite. And notice over here on the left, that's the file I promised that I dragged and dropped into the project. It's a binary file, so clicking on it won't actually show me the contents. Now here is a bit of syntax we haven't seen too much, but you might recall from Rob's lecture a few weeks back. SQLite3_open is a C function that opens a database connection. So database, notice that path is of what data type at this point in the story? It's an NS string. But SQLite3open, perhaps take my word for it, is a C function that has no concept of Objective-C classes and objects. So we essentially have to convert path from an NS string to what most people call a char star, a raw C-style string, which is just the address of a bunch of characters, a character array. And so what this line there is doing is exactly that. It's opening the file that's at that path and storing it inside of the DB pointer. All right, what's happening next? I'm selecting all words. So this is what I meant earlier about the expressiveness. This is a SQL query, and this file at the end is only going to have one such query. But again, there's other keywords like delete, update, insert, and yet others. Select is the operative word here. Here I'm declaring an NS string called SQL. In the next line, I'm dropping back down into C, declaring a statement. And then in this third line, I'm calling SQLite3_prepare_v2. This is what happens when you don't really plan your functions ahead. The names get like this. And then I'm passing in a few values, again converting from a Objective-C style object to a C style string. And let me wave my hand at some of the details there, but what this just means is get ready to execute the previously declared query. Select word from words. So what is words? Words, again, is the database, or specifically it's a table inside of the database, like an Excel spreadsheet. And Word specifically is one such column from that spreadsheet. So this is a super simple database. It essentially is an Excel file with a single column A, if you will. And column A is called, just because I named it such, Word. So it's not even really that interesting of a database. Yeah?
Where does it know from which database the query got? I mean, the table is clear as Word, but normally you also make database.table, right?
Exactly. So you don't strictly need to specify the database name. You don't need to say database.table if it's obvious from the context. And in this case, you can infer it from the context because when we open the connection, we open the connection to a specific database. So that part has already, that question has already been answered for the library. So now down here is where we're actually fetching data. So by calling SQLite3 underscore step, passing in that statement that I've prepared in the previous line, if that equals SQLite row. So in other words, if that function returns to me a row in the form of a structure, I can then proceed to do the following. This next line of code gets the 0th column or the 0th cell from that 0th column from that returned cell. And then in this next one, I convert the string that I've gotten back to what kind of object? So an NS string. And then in the last line, I'm finally back to more familiar territory. I'm adding that NS string to my property, which is an NS mutable array called words. So again, the difference here for those less familiar with C is that in C, there is no notion of an object. There is no notion of a class. It's not an object-oriented language. So to implement the idea of a string, what C does is it uses an array, so a chunk of memory. And then to represent the string, it uses a \n, a null character at the end of the string. And then it gives to you the address of the first character. So in C, if you know the address of the first character, and you know that there's guaranteed to be a null character at the end of the string, you can figure out how long that string is and what the word being expressed actually is, deer or boar or whatever it is in the database. Objective-C, by contrast, uses classes and objects, so maybe that's how an NS string is implemented underneath the hood. We just don't know. So what these several lines of code are doing ultimately is toggling back between these modes so as to use the C-based SQLite library while still using it in an Objective-C context. And then lastly, we close the database connection. And the rest of the code here, which we won't traipse through in any detail because it's pretty much the same as last week, the rest of the code just has to do with the UI table view and somehow defining the cells that you see when asked what goes at row 0, what goes at row 1, what goes at row 2, and so forth. But there's one thing I had to do behind the scenes. Recall that for quite some time under frameworks, we've had just UIKit.framework, Foundation.framework, Core Graphics.framework, which we finally started using tonight. Notice that in supporting files, there's something similar in spirit, but it's a C library, so it's called a dynamic library. SQLite3.dynlib. This is a file that I did not drag and drop into my project per se. Rather, in order to use this library, and potentially any number of other libraries that Apple provides, I went into my target, went to build phases, went to link binary, and here is where you see the list of libraries that your application is using. By default, we've always gotten those 3 Objective-C libraries. Today, I needed a 4th library, namely the SQLite library. So to get there, I had to click that plus icon and then look through a list of libraries, and you'll see there's an overwhelming number of options, suggestive of just how much more you can do with the environment if you really dive in deeper. This happens to be a C-based library, and what do you think is inside of this library? What is the point of adding this row to this configuration table? I wrote SQLite earlier, right? I wrote the various function calls. Why do I need to add something like this? What must be inside there? What's that? All the function definitions, so the actual implementations. The only thing I had to do, even though we glossed over it earlier, is in my viewcontroller.m file, I did import this .h file. But in a .h file is not the implementation of some function. That typically is in some other file. So if I actually want the bits, the zeros and ones that collectively compose the SQL-like statement query, the close query, the open query, I need to actually import those bits at link time, so to speak, and the means by which you do that in Xcode is via the project's own properties under build phases. So, FYI. Yeah?
So, most modern languages have at least one, if not 2, wrapper APIs for SQL. So, I mean, I don't mean to be lazy, but is there an Objective-C wrapper to do all this stuff?
Short answer, not as cleanly as would be ideal. Rather, there's an even higher layer of abstraction called core data, which is actually a pretty broad topic unto itself, but it's essentially an abstraction layer on top of SQL, or it can be on top of something else potentially, that allows you to define your entities and your relations without going into the depths of SQL. All of that would be generated for you. So short answer, no wrapper in Objective-C. Rather, Apple leapfrogged and went one level higher.
Third party? Is there,
Quite possibly, yeah. I've not used one, but there's not one that comes out of the box officially. Good question. So wonderfully useful, but also takes some getting used to. So keep that in mind. But much more powerful than something like a single plist file. So let me open up a little teaser here. Some of you may recall, or have at least heard of, a little game that for many years was amazing. And it looked like this. Let me go ahead and run this. I'm going to put the iPhone into a landscape mode this time. And notice that the computer is playing on the left. I, the human, am playing on the right by moving the cursor, or my finger really, up and down. And if I do this, and I can do this all day long, this will just play and play until I do something stupid, whereby if I forget to move, now he has a point. So why don't we go ahead and take our 5-minute break here. And I really lost fast there. Why don't we take our 5-minute break here, and when we come back, we will implement Pong together. All right, so first, let's resume by lowering expectations. This is an example called Paddle, which is among tonight's examples, whose sole purpose in life is to do this. But it's a good building block if we actually want to get to the point of actually having a bit of AI, if you will. You'll notice if you play the Pong game as it's been written, the computer will never, ever, ever lose, because as we'll see, the code is written in such a way that the paddle always moves to precisely where the ball is, no matter where you hit it. So only the human can lose that game. But we'll start by at least making our own paddle here. The cursor there on the screen is what my finger would be if we weren't doing this in the simulator. But first, we need a little bit of context. So let me switch over here for just a moment, just to paint a picture of how your mental model should be when it comes to graphics. So core graphics is the context. We've seen this library included for every example we've done thus far, but this is the first night where we're actually using it. And what's worth keeping in mind, is this system. Got to get better at this. This coordinate system here. So I looked for a newer image, but even Apple's documentation uses like the iPhone 3 for this example. But it's really just to paint a picture of the coordinate system in iOS, which is this plane where we have x coordinates on the right, y coordinates on the vertical. And this is just, the takeaway here is that the coordinate system begins in the top left-hand corner. So 10, 10 means 10 over and 10 down, not the opposite, as you might know from, say, typical Cartesian coordinates in algebra. So the catch is, as Apple's hardware has advanced over time, that resolutions have started to change, right? There was the Retina display in the iPhone 4 when the resolution essentially doubled, and unfortunately this could have broken a whole lot of applications. But Apple actually anticipated something like this in the sense that you don't think of graphics in the two-dimensional world of iOS as pixels, but instead as points. And a point is still just a dot, but it might be 1 pixel, or maybe it's 4 pixels. It depends on your perspective. So they introduced this layer of abstraction called points so that irrespective of the actual resolution, the operating system will double your graphics as needed or shrink them as needed. Now this is a two-edged sword. It's on the one hand super convenient. On the other hand, if you've ever used an iPhone-only application on an iPad, it just looks kind of ridiculous when you zoom in at 2x. But that's really the only other alternative would be not to let the user play it at all. So now if we scroll over to this system here, you'll see the iPhone 4 and the iPhone 5. So the annoying thing here is that Apple didn't just double the resolution, they just kind of stretched it a little bit. So there were a few more pixels now on the screen. So this was more problematic. And there's still some apps out there that you might have on your own phones that now have letterboxing on the bottom or on the top with just black bars if you have an iPhone 5 and you're using somewhat older software that the developers haven't updated. So in this case, the number of points on the screen has actually changed. It's still 320 pixels across, but it's now 568 tall instead of 480 tall. So this is why Apple, as an aside, introduced something called auto layout with the most recent version of Xcode. And we saw me use it ever so briefly earlier when I said to vertically center the label that I dragged and dropped by choosing a vertical constraint. this is the new means by which you can essentially lay things out dynamically. Unfortunately, it doesn't quite work as easily if you're implementing something like Angry Birds or something graphical where there's a pixel precision when it comes to your graphics. So some people have to actually use different graphics for different modes. And that's why we've started to see more pings among the supporting files in all the projects. One is a bigger splash screen, one is a smaller splash screen, depending on the device that someone's using. So it started to get a little more Android-like in its nuisance here. So we'll see what happens next with the iPad, which is likely to become Retina before long as well, and a higher resolution. All right, so how do we go about implementing something as relatively straightforward as this? There's some new ingredients, but what are some now familiar ingredients if we want to implement something like this? What concepts or code can we steal from recent examples to implement this paddle, whose sole purpose in life is to go up and down? Yeah. Yeah, so maybe a pan gesture recognizer so that we can actually detect the user moving his or her finger up or down in this case, and just ignore their finger if it moves along the left-right axis. All right, so let's take a look at how this begins. App delegate, same as usual. Appdelegate.m, same as usual. So no magic there. So everything must be going on interesting. I have a new file altogether this time, a pair of files called paddleview.h and paddleview.m. Let's take a look at the h file first to see what this class is, and it looks actually pretty trivial. So I'm just importing UIKit, which is pretty typical, and then I'm declaring a class called paddleview, and it's of type UIView. So this is the first time we've actually declared in code our own UI views. We've had UI view controllers, main view controller, flip side view controller, but we've not declared our own UI views. To date, where have our UI views come from? Often the nib file, by dragging and dropping. And in our no-nib example a couple of weeks ago, we did instantiate UI view objects ourselves in code manually, but even those were Apple's own UI views, the UI button and the UI text field. So this is the first time where we are defining our own view, because iOS doesn't come with a white rectangular paddle. So we have to create this somehow ourselves. So the means by which we've done this in the .m file is fairly simply by taking advantage of a method that is called automatically whenever a UI view object is instantiated. This is essentially an analog of like view did load, but that's at the UI view controller level. Now we're lower level at the UI view level. So draw rect for draw rectangle is what's called when it's time to initialize one of those little widgets that we've thus far been dragging and dropping. So here again, we're commingling some C code and some Objective-C. CGRect is the name of a core graphics rectangle, which is a C struct, a container with just data, no methods. I'm going to call this thing square. And on the right-hand side, we have a function called CGRectMake, which just returns a C structure, so a container with a few fields. And those fields are apparently 4 in number. The first two are going to be initialized to 0, third is 10.0, and the last is 60.0. Any guesses as to what those numbers are referring to? So close. Not color in this case, but dimensions. And one other detail. The XY, the initial placement of this thing. So 0, 0 is just implying that it's not going to be offset at all. It's just going to be in the top corner of whatever rectangle we're creating. The width of it's going to be 10 points, and the height of it is going to be 60 points. All right, but that's not enough. Now we've just created essentially a rectangular widget, something that could be, if Apple really liked our paddle, dragged and dropped in some future version of Xcode. Right? That's really all we've done here. But there's more complexity certainly for something like a UI button. But now let's see how we use this. In my viewcontroller.nib, notice I've done nothing except change the orientation. So if I actually click on that thing and go to the attributes inspector, one of those various checkboxes and drop-down menus would let me change from portrait to landscape mode. And that's the only change I made, in addition to then changing the background color from that default gray to black. So this is going to be my game board, so to speak. But if I now go to viewcontroller.h, nothing interesting in there. So the remaining magic must be in here. So notice inside of my view controller, I'm declaring a property that's of type paddleview, which is my own class that I created. And it's going to be called paddleview, lowercase p, capital V. Now, let's take one step back quickly. Where did paddleview.h and .m come from? Well, we haven't done this that often, though we did do it earlier with a strings file. Earlier, when creating this, I went to New, File, and then I just went up to Cocoa Touch and started with an Objective-C class, went to New. The class name I gave it was Paddle View, and I didn't have it descend from NSObject, I had it descend from UI View. When I hit Enter earlier, I got those 2 files for free, and that's when I dove in and then began to implement drawRect. All right, so now in this file, we have a few methods, init with nib name, and this looks pretty familiar except for some new core graphics code. So init with nib name is again what's called as soon as the nib is loaded from disk, but that nib by default is just rotated landscape mode and painted black. Now I want to do one other thing to it. Self.paddleView means assign to my property what? The result of allocating a paddle view object and initializing it with a frame. So here there's a bit of a dichotomy. Now I am initializing this paddle view object to be inside of a canvas. So whereas before, if you're familiar with Photoshop, I created like an image. Now I'm creating the canvas on which to place that image. So the image can be offset in the canvas itself. The canvas can be bigger. And in this case, the canvas is going to have this image view, this paddle view placed on it 10 pixels to the right, 10 pixels down, and then the width of this overlay is going to be, as we'd expect, 10 points wide and 60 points tall. So what does that mean in real terms? This is why when we start this thing, let me quit the simulator. So if unfamiliar, you can double tap there, click and hold, quit paddle, or you can just click stop, and then you can hit run again to rerun this thing. Notice that it starts in the top left-hand corner, but the projector is kind of, the contrast isn't great. Take my word for it that that paddle is not truly in the top left-hand corner of the iPhone. It's instead 10 pixels down, 10 pixels over. So it itself is, with respect to itself, in its own top left-hand corner, but that's just because the image itself was only 10 by 60. Now we're painting it on a canvas by offsetting it 10 by 10. And why? I just thought it looked marginally prettier to offset it slightly from the edge of the phone. No other reason. All right, so if we now go back into viewcontroller.m, what more is happening here? This line of code, add subview. We've not done this before, but we've kind of felt the results of a line of code like this before. Thus far, when we've dragged and dropped things like buttons and text fields and sliders from that little menu and interface builder and dropped it, we've been adding a view on top of another. In other words, adding a subview. This is the corresponding line of code to dragging and dropping in that interface. I'm taking my paddle and laying it on top of the game board itself, which is just that big black rectangle by default. Okay, so now, turns out, making this super simple and kind of pointless game is as simple as implementing the touches moved method. So the touches moved method is a little different from the pan gesture recognizer that we implemented earlier. Touches moved actually allows you to detect all sorts of touches on the screen, multiple fingers, touches in different locations. And it turns out this actually makes it even easier to respond to those key presses, though we could have done this in different ways. So touches moved is going to be fired anytime a UI view is touched on the screen. And what's going to happen here is this. When this method touchesMoved is called, actually the method is called touchesMoved with event, I first ask the event that I've been passed as my second argument, give me all of the touches, and then give me any object. This essentially gives me, in this case, the only object that could have been touched. If there had been a whole lot of things on top of one another, it's possible that multiple things would have been touched because of the various, the z-axis, so to speak. But in this case, there's only one paddle on the screen, so I only care to get whatever's in that set, so any object will do. I then, with this line of code, ask it for its location. What are its XY coordinates, essentially? And I store those in something called a CG point. A CG point is just a tuple, x comma y. So where on the screen was that finger touch? Now, what do I want to do? So I don't care where the user's finger is along the x-axis. I only care where it is on the y-axis. So I don't care if the user goes up, down over here or goes up, down over here. He or she is only going to be able to move the paddle along some fixed axis. So which value, .x or .y, is of interest to me here? The location .y. So if I want to center the paddle, notice what I'm doing here. It turns out that center is a property associated with the paddle view, or more generally, any UI view has a center, and I need to assign it an x, y coordinate, I'm actually not going to bother. I'm actually going to change its y location, but I'm not going to change its x location because I don't want the paddle to start moving along the x-axis in this landscape mode. I only want to update the y-axis. But I need to assign its center an x, y coordinate, so I have to actually give it a point, and CG point make gives me that tuple, gives me an xy pair. So in the end, we get this very simple, kind of pointless game where the thing follows my mouse or my finger perfectly no matter where on the screen my mouse is without actually responding to the lateral movements. Yeah?
Can you constrain the touch and all touches to be like, inside of OPEC as well?
Absolutely. We could constrain the touch to only work, for instance, if actually touching the white box by actually looking at the x coordinate and the y coordinate and saying, are you within some certain bounds? If so, move. If not, ignore. Absolutely. And we can kind of change the functionality of this thing altogether if I instead change this line here from the same x that it currently is to location.x. What's going to happen if I now run this version? It should follow my finger, or in this case, the mouse pointer. So if we go to the simulator here, boot this up, and this is kind of a stupider game now. Well, actually, you might have an advantage now if playing Pong. All right, so what remains to be implemented? You saw Pong a moment ago, and you might have played Pong years ago. So we've got the beginnings of it. We've got the user's half of the game. What more do we need to do? Yeah? Yeah, so we need to implement some kind of little white ball that's going to bounce back and forth. In fact, the bouncing sounds kind of interesting because if it hits the top or the bottom, we need to do some kind of reflection, like on a pool table or like from geometry. So we have to think about that. What else has to be implemented? So the tally. So we have the big score at the top. So maybe that's a UI label. We could kind of cut some corners and not do everything in graphics. We could actually just use a font and actually update two labels for the left guy's score and the right guy's score. It's collision detection of what? Yeah, exactly. In addition to the top walls from which we want some bouncing to happen, the end walls mean a point has to be scored. So we have to somehow detect if you've gone too far left or right with the ball. And we've got to detect if you've hit the left or the right paddle and that ball has made contact. So there's a lot more to think about, but these are all probably building blocks we can start to piece together. So let me go ahead and open a final form of this and see if we can pluck off it piece by piece and see what the origins of each trick are. So here is, I propose, a working solution. And even I kind of cut a corner here. Based on the files you see here, what corners have I cut thus far? Really just in the interest of simplifying things we've already looked at. Yeah?
You didn't make a specific new class for the ball.
Yeah, exactly. I have a Pong view, which as we'll see kind of manages the whole game. But I don't have a paddle view anymore, and I don't have a ball view, because I realized along the way that it'd actually be a lot easier to make a paddle in Photoshop and a ball in Photoshop and just import pings. And so I seem to have done exactly that. Paddle.ping and ball.ping are just going to be graphics, but that's not enough. I can't just plop pings on the screen. What what class do I have to wrap around these images, as we saw with Rob before? So a UI image view. So we're just using a different UI image view rather than making absolutely everything from scratch. So we'll start as always in the app delegates, nothing going on there. AppDelegate.m, nothing new going on there. Other than, actually this is one good thing to highlight, we've used the app delegate for terribly little other than the built-in functionality. But what do I seem to be doing with this application will resign active? A bit out of context now, but take a guess. What does this mean, and what am I doing in response to it, do you think? How about the first question first? When does this method, application will resign active, likely get invoked?
When you get from the background.
When I what?
Get back from the background.
Close. Just the...
Will resign.
Will resign.
Will it go background?
Go ahead.
When you flip the form
So it's not actually orientation. It's instead when the app is backgrounded. So if I get a call and I take it, or if I push the home button and I resign active state. Remember when we made made the key an active window earlier? This is the same idea, the opposite of that. So what am I doing? I'm apparently passing a message called kickoff to self.viewController. And I only know this intelligently in hindsight. The first time I sat down to implement something like this, anytime I did get a call or anytime I backgrounded the application, then came back to the application, I immediately lost because I had no recollection of where the ball was. My brain wasn't quick enough to actually tell my finger to move the paddle to catch the ball. So I realized, wait a minute. If the user has to effectively pause the game to take a call, respond to an SMS, background it, whatever, it'd be a nice courtesy to pause the game. So kickoff does effectively that. It just moves the ball back to the kickoff location. The idea being, I figured, let's just start from let's not reset the score. Let's just reset the ball's location to the middle, like you might have in a soccer or football game. All right, so that's the only difference there. PongView.h doesn't seem to have much going on here. PongView.m looks like this. Not too much, but a little of this low-level stuff. And I thought I'd draw something different. Let me open up the game again. And in the simulator, there was one other design element on the screen. Does anyone remember what? I think I heard? Yeah, the dashed line in the middle. So this is surprisingly non-trivial to do. And I didn't want to resort to Photoshop for everything, but I thought that kind of looked like a nice line down the middle, and we can draw this using core graphics on top of my canvas. So in this case, I first need to get something called a context. And the context you can kind of think of as like the canvas, the current context for your graphics. And now we have some sort of weird use of C, but in the end it's fairly straightforward. I'm first declaring a variable called dashes that's of what data type? It's of type CG float, but specifically it's an array of CG floats, whatever that is, core graphics float. So it's some representation of floating point values for this particular library. 1, 1 is essentially, as we're going to see, it's going to mean draw a little bit of white, then have blank space. White, blank, and that's how we get the sort of zipper effect up the screen. All right, so CG context set line dash. So this function is essentially saying, what's your canvas? Dashes is what pattern do you want to use? And 2 just means how big was that array. Next line here, CG set stroke color with color. What's your canvas? What color do you want me to draw in? So in this case, this is a bit of commingling of C and Objective-C. UI color is a class. White color is a convenience method or class method inside of that class that returns to you some Objective-C representation of the color white. .cg color converts that NS object, that UI color object to a C-style struct for the core graphics library. Down here, we set the line width to be fairly arbitrarily 5 points wide. We move to the point 240, 0, so we're essentially going to the middle of the screen if we assume 480 points total. Add line to point. This is saying go from where you are all the way up to the top, so sort of draw that dashed line. And then lastly, fill in the dots, so paint along the trail you've just left. So if you remember like a language like Logo years ago, the little turtle turning up, down, left, right, and drawing things or leaving a trail, it's the same kind of idea where you move a cursor around and you tell it when to put the marker down and draw, when to let go, and so forth. We've essentially drawn a dashed line in that way. And now the whole point was, again, to overlay on top of our view this Pong view. So here we have viewController.h. We're almost into the brains of the game. ViewController.h apparently declares one method called kickoff. Why did I put it in my .h file? I feel like I'm regressing to our previous techniques. Yeah?
Well, because you called it in a different class, which means you need the other class needs to know that there is a kickoff.
Exactly. In my ViewController, in my AppDelegate.h, recall that I AppDelegate.m, recall that I called the kickoff method in this line here, and that's why I imported ViewController.h, and that's why in ViewController.h I'm actually declaring this method publicly, so to speak, in the .h file and not in some nameless category in the .m file. All right, so the nib file looks like this, and it's a little different this time in that I seem to have laid out in advance a few different widgets, so to speak. What appears to be on the screen here? So some text. So I conjecture this is a UI label. That's another UI label. And I just put some default text there, even though the human never sees it. What else is on the screen? Yeah. Yeah, so the image views. So let's take a look. If I first expand the hierarchy here, I can see what I've laid down on this canvas. And indeed, there's 3 image views, or UI image views, the class name, and 2 labels. And if I actually click on these things, we can see how they're configured. Let me click on the ball in the middle there. It's 10 pixels by 10 pixels, according to what I made in Photoshop. And it's indeed a UI image view whose image source has been specified to be that ping in question, just like we did with the rob.ping earlier. Same deal for the others, and score left and score right, if we go to the identity inspector, is indeed a UI label. So in this case, what I literally did in advance was I dragged and dropped 3 UI image views from the palette of options down there. Then I configured them, just like we did with Rob earlier, to be ball.ping or paddle.ping, so as to lay that out. And then the scores, I just manually typed. Previously, they just said label, and they could still say label. I just thought it was a little more instructive to give them left and right names. That's all. All right, so now if we go to viewcontroller.m, here's where all the interesting stuff must be happening. So first, I decided, just to make it easy to tinker with my game, to declare a velocity constant at the top of the file, initialized to 10.0 in a floating point value. So this is like the speed, 10 points per second or some unit of time. And then I have inside of my nameless category a CG point velocity. So somewhere in this class, I need to keep track of what is my current velocity. Because a velocity, recall, is essentially a vector telling me how fast to go straight up, or to the right, or the opposite thereof. So it's some kind of speed, a change in rate, dy dx. So I need to store my current one so I know at every second of the game how fast should the ball be moving. Now I have a whole bunch of private properties here, but most of them are as expected. I've got IB outlets for all 3 of the UI image views that we saw earlier, and I've got 2 IB outlets for the UI labels that we dragged and dropped. So that leaves a few here. NSU integer, what might that mean? Yeah, so it's an unsigned integer. Why? I figured the score never needs to go negative. So just to be proper, I'm going to specify that it's an unsigned, that is non-zero integer. I could have just done little u unsigned int, but just to be consistent with iOS practices, I gave it the NSU integer, which is just it's not a class, it's just a type def. It's a synonym for unsigned int. All right, I've got one for the left, one for the right, and bool for paused. I needed some variable just to keep track of whether or not the game is paused, and when does it seem to pause, based on our tinkering earlier. What's that? When it's in the background, and also in the beginning, when the ball is just sitting there in the middle before I actually start interacting with the app, or conversely, every time there's a score made, then the ball goes back to the center, and I have to touch it for the game to resume. All right, so now in the view controller, a lot of this now is just logic. So after initializing the object with the nib name, I'm initializing the score left and right to 0. I'm first declaring a velocity. So a velocity has to do with motion, and yet you can represent it with a point. If a point is just x comma y, you can just treat the x as delta x and the y as delta y, change in x, change in y. So I just use the now familiar CG point make, velocity comma velocity, and this just means if it's 10.0, what did we say it was earlier, the constant? 10.0, this just means for every unit of time, move 10 points this way, 10 points that way, effectively going on a straight diagonal. All right, so what happens next in this initializer? This is how the game actually has motion. So we declare what's called an NS timer. We schedule it with a time interval of 0.05. So every 5/100ths of a second, I want something to happen. And I just decided on that by trial and error to see what would feel right. Targeting myself with a selector of play. So apparently, I want what method to get called every 0.05 seconds? The play method. All right, and beyond that, and it repeats in that if you recall from JavaScript, there's set interval and there's set timeout. This is like set interval, given that I'm passing in repeats a value of yes. So now what happens next? Nothing seems to happen there by default. Let me scroll down. There's a play method. A lot of math there. Touches move. So touches began. So it looks like what I'm doing here is when there's a touch on the screen, I'm changing the value of paused to no. So this was my way of kick-starting the game. As soon as touches begin on the screen, doesn't matter where the human touches, that means kick the ball. Let's start the game of Pong playing. And I change that Boolean field. So presumably, my play method is going to check that value. So let's go into play here. And indeed, if the game is paused, just return immediately. Don't play anything. Don't do any mouse movements or cursor movements or ball or paddle movements. Otherwise, move the ball. So this is very similar behavior to before. Even though this is being called on a timer, not in response to user action, what do I want to do every unit of time? I want to move the ball how? Using its velocity. So if its velocity is 10, 10, every time the clock fires, I want to move it over 10 and up 10, if that's its current velocity. And that's what I'm doing. I'm making a new point, taking the ball's current x location, adding the velocity's x value, then comma, the ball's current y location, and adding the velocity's y value. But now I have to somehow detect when the ball is in the goals, as was proposed earlier. So what is this line of code saying? If self.ball.center.x less than 5. What's the implication of that logically?
Position with respect to a certain boundary that it pretty much knows that it's some sort of desired threshold.
Exactly. So recall that 0, 0 is the top left-hand corner. So if the ball goes within 5 pixels of 0, it's really all the way over to the left, at which point I'm just going to say that's a goal. It went over the boundary. So who should get the score? The guy on the right. So score right should be plus plus, because he's the one who would have kicked it into that end. And then I call self kickoff. Well, what does kickoff do? Let's come back to this function and this method in just a moment. Kickoff does a few things. It pauses the game, apparently. It then updates the scores based on what's in the NSU integer. So the unsigned integers are numbers, but I want to turn them into strings so that I can paint them on the screen in terms of those labels. So that's using some building blocks from a few weeks ago. Now I want to center the ball, and I'm going to go ahead and center this at that particular location here. And then I'm going to go ahead and align the paddles, which was just a bit of trial and error, figuring out exactly what made sense on the screen. And now if I scroll back to play, what happens otherwise if there's no goal on the left or on the right? Well, bouncing is kind of an interesting thing. So what is this if condition handling? The highlighted lines are doing what and how? Yeah?
All it's saying is if it hits the top or bottom, all you need to do is switch the direction of the y part of the velocity.
Okay, good. So as the comment says, this has to do with bouncing off the top and bottom, but how? Well, if the y coordinate of the ball center is less than 5, that means it's really close to the top. And if its velocity at that point is some value, how do you make it stop going upward? Well, just change the velocity to negative. So if we effectively want to make right angles when we hit the side of the wall, it actually suffices. If, again, you think of the motion as an x component and a y component, if the ball is going up this way, you don't want to change the x motion. Like, you don't want it to go this way, because that would be weird if the ball hit here and then went this way. You want the ball to go this way and keep going to the right, but you want it to start coming down. So all you have to do is flip the y from positive to negative, or conversely negative to positive, and that's exactly what we're doing inside of this if condition. If we get within 5 pixels of the top of that screen, go ahead and flip the y's velocity, as with that negation there in that line of code. And the or is just handling the bottom of the wall as well. And the fact that I'm using a negative sign here means it doesn't matter if the ball is going up, now it'll come down, or if it's going down, now it's going to go up. The left paddle is a little more interesting. And how are we apparently detecting intersection? Well, it turns out in the core graphics library, there's a helper function called cgRect_rect, and you can pass in 2 rectangles, and it will return true if they're overlapping, which is perfect. And this is why I didn't quite make the ball a circle. I decided it would be easier to just make it a 10 by 10 square. So this way, no matter where it touches, it's sort of geometrically reasonable to assume that it's going to bounce. And so in this case, if the frame intersects, the frame of the ball intersects the frame of the paddle, then go ahead and inverse the velocity from negative to positive or positive to negative, depending on which paddle you have just hit, if you're on the left or you're on the right. Yeah?
If you would increase the velocity of the ball, would you get a problem with this bunch?
if you increase the velocity of the ball, would you get a problem? Define problem.
That the ball is already too far, like it doesn't really intersect
Oh, good question. Yes, so potentially. I have made certain assumptions about the thickness of the ball, the velocity at which the ball is moving, and how frequently I'm firing the clock timer. I could absolutely come up with values whereby the ball could be here at one firing of the clock, and then here at one firing in the clock, and the paddle could have been here in the middle. So that would just be a mathematical mistake on my part, and something that I'd run the risk of if I had variable velocities. But all I'm doing with my velocity here is just inverting it, positive or negative. Good question. Other questions here? All right, so here is my artificial intelligence. If you really want to have basic AI in your game, really all I have to do is tell the paddle to move toward the ball along that y-axis, and so long as he can move just as quickly as the ball, he will never make a mistake. So what am I doing? So if the velocity at which I'm moving is negative, what does that actually mean? If the ball is moving left, so that means it's coming at the computer's paddle. My paddle was on the right for this version, computer's on the left. So if the ball's moving this way, that's the indicator, according to this code, that the computer AI should start doing something. So if the ball's center y component is lower than the paddle's y component, the paddle should, per the next line of code, move its center toward the ball. Conversely, if the ball's center is higher than the paddle should move up toward the ball. And so no matter what it seems, this paddle will always keep pace with the ball, and really only I, the human, am ever at risk of losing. So let's see if this is indeed the case. If I run this version of the game, we now have two paddles on the right. If I click, that's when the kickoff starts. And notice he only moves when the ball is coming back at him because of that check. Though we could add some randomness. If we really wanted to give the human a fighting chance, we could have the paddle keep moving somewhat randomly. We could change its speed. But for the most part, we have a pretty boring game. But we could make it more interesting if we go back here. And what could make it more interesting? How about we change this to 30 points per unit of time? Now, if we rerun the program, we'll get a game that's a little harder. And come on. Now if I click, damn it. Oh my God. There we go, thank you. Okay, so it's really hard now. What else could we do? Well, I mean, if you could imagine making this into even more of a game, maybe like a utility app where it flips over, you could change the size of the paddle, kind of like a game Arachnoid years ago, where things get harder or easier depending on the settings. So there's a number of things you can do with this. But at the end of the day, we really didn't write all that much code, right? We asked iOS to inform us when is the movement happening with the touches, so we can respond to that. Then we drew some things in advance, but we've seen that we could totally skip the Photoshop step and just draw these paddles as their own classes, instantiate them, and do something almost identical with the ball, just making it a little smaller. And at the end of the day, the only thing that I'm doing here is I'm borrowing some code from my paddle example. Anytime there's the touch is moved method is called, and that means something has happened on the glass with a human's touch, I'm going to ask, give me one of those touches, figure out what its x comma y is, and move the right-hand paddle to that side of the screen. So really, the human side of things boils down to just those 3 lines of code. So we have yet another few pieces of building blocks there. So any questions on our first 2-dimensional game? Mm-hmm.
Are you somehow preventing the paddle from being pushed off the screen, or does Apple have something built into the system that can push the paddle off?
Good question. Am I doing anything to prevent the paddles from pushing off the screen? Yes, I am, in the sense that my code is only ever altering the y-axis of the paddle. I'm only allowing it to move up and down. So notice here, recall this line of code from our previous example. The paddle on the right, his center, is only ever being updated according to the y-axis. So notice this value here, the x value, this is literally the paddle's current x location. because it's self.paddleright.center.x. So what is your current X location? And the fact that I've pasted that as the first argument to cg.make means whatever your X location is now, it's going to stay that way, because that's the new point that I'm making. But location.y is coming from what? From the human touches, based on these two previous lines. So in short, this third and final line of code in here is just ensuring that the paddle center will absolutely be able to go up and down, but it will never respond to left-right movements. But we can decouple those. If I go back, just like I did last time, and say, go ahead and let the user have location.x, and now run this. Now this game's, I can't do 30 points per second, 10. Now this game gets a little more interesting in that I have a bit of an advantage where I can just kind of chase this, oh damn it, over there. So that has to do with the refresh rate, so to speak. So now the math is a little off in that I can't assume a certain axis, but now I have decoupled it from that axis.
But I meant on the y-axis, like why when you push it all the way up is it not going on screen?
Oh, it is. I'm just stopping. My mouse can't quite pull it all the way up there. But yeah, it's going off the screen somewhat. And we could detect that too, because we know the height of the thing, and we could just ensure that you couldn't go any higher than the glass.
You don't have to safeguard it necessarily because you can't click off screen.
In this case, but if you've ever been bored, like, what do I usually do on my phone? Sometimes when you're really bored in iOS, you can start using your thumbs and like start pulling down on Safari to see how far. So other people have done this, yes? Okay. So someone has checked for that in Safari. We have not checked for that here. So in theory, you could get it to go off the screen and probably get it such that you maybe can't get it back, depending on where it's detecting the finger press. I'm glad that's normal behavior. Okay. All right. Any questions then? All right, so what lies ahead? Well, Evil Hangman is still in front of us. On Wednesday, we're going to take a direction in a lab that's not specifically about the final project because there is no one specification. It's up to you guys to propose this. We'll have the specification posted for it on Wednesday, but it will essentially boil down to come up with an amazing idea, propose it to your TF, and await his confirmation or requests for modification to the idea. And the request won't be, we don't like your idea. It will be more, we don't think that's realistic in 2 weeks, or we think that's too realistic in 2 weeks, just to give you a sense of calibration so that you can bite off something that you can indeed chew. And what we'll do is try to calibrate you so that you have a threshold, a quality threshold that you'll definitely meet, and we'll also try to push you a little bit to have, say, a good, better, best version of your application, where it'd be amazing if you get the best version, but we'll be quite pleased if you get the good version out the door in time for that app party. So in lab this week, what Chris Gerber will do is introduce you to some more advanced techniques in iOS to further seed your minds with opportunities. Even though the proposal will be due shortly thereafter, realize you can change your mind. If you realize, wow, I love the accelerometer, I really want to do this instead, just make sure to have a two-way conversation with your TF to make sure it sounds like a reasonable change. Why don't we officially adjourn here tonight, and we'll see you next on Wednesday.